we are going to write transformed functions, which means I want to take this function and perform the transformation and find the new equation. We can use Desmos to check to see if we did it right. We put in original equation, we put in our final answer, and see if it actually did what we wanted it to do. So the instructions will say write a function g whose graph represents the indicated transformation of the graph of f. So the first example, f of x is equal to the absolute value of 2x plus 1. We want to translate it to the left 3 units and then up 4. When we are doing this writing, we don't think about the order that we use to describe, because we are telling you in the instructions to do it in this order. So we might get different equations if we don't do it in the order that we say to. Okay, so we're going to just follow, if it says do this, then this. That's what we're going to do, even if it goes against the order we talked about yesterday. Okay, the order is yesterday is when we're given the equation and then we have to perform it, or if we're describing it from an equation. So what's the first thing I'm going to do to this function?
Determine if it's horizontal.
No, but I'm going to translate it 3 to the left. That's my instruction. First, translate it 3 units to the left, then translate it up 4. Okay, I want to move this graph to the left 3 and up 4. Now, to the left, is that horizontal or vertical? It's horizontal. Where does horizontal go, inside or outside of the function? It goes inside. We're going to write our f of x notation. F of, how do I write in this notation to the left 3? X plus 3, yes. It was opposite, right? Left is usually negative, but horizontal is opposite, so it's x plus 3 that's going to move it to the left. Now we're going to do that transformation. We did this last week. We substituted and evaluated functions. If I said find f of x plus 3, that meant plug in x plus 3 for the variable. So we have the absolute value of 2 times my transformation x plus 3, because that's what it means when it's inside the parentheses, right? It's going to replace the x plus 1. And we're going to simplify that. How do I simplify 2 times x plus 3? I get 2x plus 6 plus 1. And that's the absolute value of 2x plus 7. So now I've moved it to the left 3. What does it want us to do next? Up 4. Well, how do I write up 4 in that f of x notation? F of x plus 4 on the outside, right? Up and down is vertical. Vertical is outside the function. So I'm going to take what I got from step 1. That's the new f of x here, 2x plus 7. And then we're going to add 4. Now, am I allowed to add into that absolute value? No. Okay. I can substitute if it's x plus 3, but I can't if it's plus 4 on the outside. So my final answer, g of x, is the absolute value of 2x plus 7 plus 4. That's my new function. Now, should we look at it in Desmos to see if it did what we wanted it to do?
Yes.
Okay.
No.
Yes, no, can't decide. Let's see. In Desmos, the original function was 2x, was it plus 1? Okay. So there's the original. The vertex is there at 0.5. What's the new function?
2x plus 7 after the value and then plus 4.
So did this move 1, 2, 3 to the left? Yeah? Did it move up 4? Yes. So our new equation is correct.
How are you supposed to count that? They don't have the markings.
Well, there's markings. It says 2 here. Right?
Yeah, I can see that.
So then I know that's 1, starting at 1/2. Okay. Okay. Let's do the next one. These transformations are the same whether we're using the square root function, the quadratic, which is x squared. So we're going to throw in some different functions so you get practice using them. F of x in this case is -3 times the square root of x plus 2. We want to move it down 3, and then we want to do a vertical stretch factor of 5. So first is down 3. Second is a vertical stretch factor of 5. How do I write in my function notation a vertical translation down 3? What minus 3? Wait, I just want my function notation. F of x minus 3. Okay? You need to get into the habit of writing that notation and not just jumping to the equation. And it's because we mess up the horizontal translations all the time when we don't take the time to write it correctly and then realize what we're substituting in. So now I can then take my function f of x, -3, square root of x plus 2, and then I can subtract the 3. Now in this case, the parentheses are pretty irrelevant. So I'm just subtracting, and I can combine the 2 and the -3 because they are outside the square root. Right? Just like I can combine anything that's outside the absolute value. If the square root bar continued over the 2, I would not be able to combine them because the 2 is under the radical and then the 3 would be outside the radical. So if it was like this, okay, we can't combine the 2 and the 3 because that 2 is under, okay? So what do I get when I combine those? -1. Okay, -3 times the square root of x minus 1. Now we want to do step 2, which is a vertical stretch factor of 5. How do I write that in my f of x notation? Function notation. Right, 5 times f of x. Shrinks and stretches are always multiplied. I'm either multiplying outside or inside. Vertical outside, horizontal inside. So that means I'm going to multiply the whole equation by 5. And I get g of x equals what? -15 square root of x minus 5. Okay, make sure you distribute the 5. Yes?
Where'd you get the brackets from?
I'm just putting the brackets around the function so that I know what I'm multiplying that to. I could use parentheses instead, but sometimes the brackets I feel like stand out better. So it's no different than putting parentheses around that. Okay. Do you want to look at it in Desmos? Let's see. Sorry? Oh, man. I took the window out. No, I just wanted to use it. Okay, it doesn't want to. It's making me get a new browser window. Okay, so it was -3 square root of x plus 2 on the outside. Kind of a funny looking graph here, right? Yes.
How come you don't write g of x on the first step?
On the first step? Because it's not g of x until I've done both transformations. Okay. So we'll write g of x once we're done. Now, if you wrote g of x in the middle of your work, it's okay too. There's nothing wrong with that. What's my new equation? It was -15 square root of x minus 5. So it moved it down 5. It's really hard to see. No, it moved it down. Yeah. And then it stretched it. Okay. Thank you. Okay, here's our last example. But there's a problem. If we're going to take f of x equals 3 plus the absolute value of x plus 7, we're going to do a reflection in the x-axis followed by a horizontal shrink factor of 1/4. If the factor is 1/4, it's always a shrink. So how do we write reflection in the x-axis? We write negative times f of x. Reflection in the y-axis is f of negative x. Now remember, we gave you that cheat sheet of notes on the back of the worksheet on Wednesday. Use that to help you write the function notation. So that means I'm going to take f of x and I'm going to multiply the whole thing by a negative. So 3 plus the absolute value of x plus 7 times that negative. The negative distributes to the 3, and it distributes in front of the absolute value. So we get -3 minus absolute value of x plus 7. I cannot distribute into the absolute value under the square root, into this parentheses squared. I cannot distribute into the function when I'm doing a vertical transformation. The only time I can put it inside is with the horizontal transformations. And the second thing we're going to do is horizontal shrink factor of 1/4. Horizontal is inside, so the way we write that is f of, remember, the factor is not what goes in our equation. The factor for horizontal is the reciprocal of what goes into our equation. So we're going to put 4 into our f of x. F of 4x. Remember that shrinks and stretches are multiplied, reflections is a negative, and translations left, right, up, down are addition or subtraction. So f of 4x, I'm going to take 3 plus the absolute value. I'm going to substitute 4x in for the x plus 7. Now I can put parentheses around that, but there's nothing to multiply it by. If it was the absolute value of 2x plus 7 inside, this is just a big if, it would be 2 times the 4x plus 7, remembering to plug it in for the x. So my final answer, g of x, is 3 plus the absolute value of 4x plus 7.